All right, welcome back to section 5 of the Scrape the Planet course. We're going to be starting right where we left off before with an interesting question. Now, I know some of you probably like Apple. I personally hate the company, but I love their phones. But as an investor, you're not only going to be watching just one stock, you have several that you're probably interested in. So instead of just importing or instead of just watching one stock at a time, we want to import a file full of stocks and full of lows and highs that we're interested in. This would be like creating a watch list on trading platforms like Thinkorswim is one of them, and there are a couple of other trading platforms that I've never used that also have watch lists. This is going to be a very, very rudimentary version of that. And we're going to talk about something very, very cool to make it way faster. So, instead of importing our tickers, lows, and highs like this, we're going to import them into a file. Ooh, we don't want to comment out all of that. So we're going to be working with a file called stocks.data. So stocks is equal to open./stocks.data, and we just want to read it. So we're going to very quickly just read all the lines in. We'll just call it lines is equal to stocks.read lines. And we're going to close stocks. Close. Now, we are going to load an object in. And this object is going to be stocks obj. It's actually going to be a dictionary, sorry, not an object. So let's start putting actual stock objects into that file. So into that object. So for line in lines, the ticker is equal to, well, let's split it first. So here's the format that we're dealing with. I think I should actually show you the file. We've got our ticker, we've got our low value, and we've got our high value. And I've pulled all of these like essentially manually from the Yahoo Finance app or the Yahoo Finance webpage. So they all should be scrapable, but we looked at Microsoft last time that for whatever reason wasn't. So here are all of the tickers that we're interested in. There are 7 of them, and we're going to start pulling those in one by one. So we've got, well, I guess you don't really need to see this the whole time. So for line and lines, our ticker, well, let's just split it first, obviously. SPL equals line.split at commas. Then our ticker is equal to SPL at 0. We're going to strip it just in case it contains anything nasty. Our low is equal to SPL at 1. Strip, same thing. And our high is equal to SPL 2. Strip, and that high probably should have a new line attached to it, so we obviously don't want that. And then our stocks object, obj, at our ticker is equal to the low, and the high. This is going to make it very, very easy for us to access those things. So now we've got our object loaded in. Now we actually want to do things with it. So at first, we're going to time how long it takes for us to run through all of these the way that we're doing it right now. So time equals, well, let's do start is equal to time.now. And then we're just going to run this once. So we're going to take this out of the while loop. Actually, let's run it a couple of times. So for x in range 0, let's say to 3. We're going to run it 3 times. And let's do end is equal to time.now and print the runtime. Runtime end minus start. So that's going to show us how long it took for us to run through 3 iterations or 3 basically, we're going to run through this entire list 3 times. So we're going to have to change the loop just a little bit. So for key value and our object is called, or a dictionary is called stocks underscore object, stocks underscore obj dot items. Then our ticker is equal to the key. Our low, let's see, our low is equal to the stocks underscore obj at the key at low. And our high is equal to the stocks underscore object at key at high. And we're going to convert both of these to floats, just right off the bat. And then pretty much everything else is going to be the same. So we can basically just take all of this and indent it once. So we're going to print running through the list for the X time. And that's going to tell us how many times we've already run through the list. Then it's going to run through our list, and then we're going to sleep. Yeah, let's sleep every time. It's going to take a while for us to run through this, but there's actually a purpose here. So let's run this and see if it actually runs. Probably won't. I'm sure I screwed up something. Let's run it. Getting that same error there. Clear for good luck. Python./s5 underscore p3.py. Shouldn't need any kind of input. We don't have a config.txt here. Oh, I guess we don't, do we? So let's drag over our config.txt. That was dumb. Got to open here somewhere. There we go. Right, let's drag this over into config.txt. Save it. And that is the same database information that we had before. Nothing sexy. Clear it once for luck, twice, 3 times for luck, and let's roll. Oh, I grabbed the wrong config file. So this is supposed to be .8 testdb testdb password. Now we should actually have output. I've got like 1,000 config files just running around, and luckily none of them contain anything super useful. Time has no attribute now. Maybe it's date. I think it's datetime.now. Datetime. I bet it's datetime.now. Because that just seems like it would be the case, honestly. Datetime.now. I hate the way that you have to access things in here. You either have to import datetime from datetime, which just seems dumb, or you have to do datetime.datetime for everything. Yep, there we go. And now we're sleeping after everyone, and could not convert string to float. Oh, so there are some cases where the price is actually in the thousands per share, which is just absolutely bonkers. So we need to strip out commas in that case. Let's see. So our price is equal to page pull ticker dot strip, and we are going to strip out commas. Clear once, twice, 3 times for good luck, and let's run it. Let's hope that works. It should be able... Nope, sure doesn't. Let's just do replace. Maybe that'll do it. Replace that with nothing. That should work. Theoretically. Maybe. Yeah, that worked. There we go. Alright, so I will be back when this actually finishes running, and it's actually going to take quite a while to work. Alright, so as we can see, it took the scraper 1 minute and 12 seconds to run through every object in our list. Now that's not bad. I'm not saying that it is bad, but let's just say we wanted to make it faster. Here's a really great way to do it. We're going to jump over to the whiteboard and talk about multi-threading. And I'm going to give the same disclaimer that I've given about just about everything else in the series except for actually writing web scrapers. I am not an expert in multi-threading. I'm not an expert in figuring out when multi-threading is the, God's gift to humanity. But I do know how I've used it before, and I've got a couple of essentially practical tips on how to use multi-threading for scrapers. Now, if you don't know what multi-threading is, you've got basically two different kinds of programs. You've got linear and you've got parallel programs. And that is verbiage that I am almost sure that I'm screwing up. So a linear program has a list of instructions and it runs through it linearly, one after another, after another, after another. A parallel program has a list of instructions and it's going to divide that up into threads. So you've got a thread here, you've got a thread here, you've got a thread here. And what threads are you can basically view them outside of the operating system stuff. And I'm not going to go into the operating system specific part of it. But you can think of them as separate instances of your program that are going to run a certain function all at the same time. So instead of one thread, which is basically what a linear program is, it is one thread that is running everything linearly. You have multiple threads that are all running the same instructions with different inputs at the same time. So in our case, what we might want to do is create a thread that is scraping Apple, A-P-L. And then we've got another thread that's scraping Microsoft, which doesn't work. And then we've got another thread that is scraping Tesla. That hopefully works. All of these can run concurrently, meaning they can all run at the exact same time, processing their respective web pages all at the exact same time, and speed it up because you're, instead of running one ticker at a time, you're running 3, or you're running 5, or you're running 2, or you can really, you can define exactly what this is going to look like. So, what are the downfalls? Why don't you just multi-thread everything? And quite honestly, there are lots of things that you could successfully multi-thread. There are lots of things that should not be multi-threaded. And the biggest reason why some things should not be multi-threaded is called a race condition. So let's say you've got a piece of data right here. And you've got a function that is going to read from the data. So let's say func read. And you've got a func write. And let's say this read data is just going to process it a lot, and then it's going to make a decision. And it's going to decide based on the data that is found within, this piece of data. Let's say it's a database. So a big database server that looks like every other database server that I've ever drawn, meaning it is an ugly, horrible rectagon. Did I just really say rectagon? A really ugly cube looking thing. And then you've got your write, and it is a function that is going to write to that database. So you've got a read from and a write to. Now here's the problem. If you multi-thread this, if you've got a function that's writing to the database and a function that's reading from the database, your read, in the case of a race condition, it might, at second 1, read from that database, and it is going to read, let's say, x equals 7. Let's just say you've got random numbers in this database for whatever reason. Don't know why you would do that. So at second 1, it is reading from that database at x equals 7. At second 1.1, your write function is saying, no, x is equal to 11. And this is reading x is equal to 7. Now the problem that you have here is that in 1/10 of a second, x is changed. But at second 1, your read function is reading the wrong variable. It's already reading an out-of-date variable. It's reading data that is no longer valid. Now, if your read function is making decisions that are important, if it's making decisions on whether or not to buy or sell a stock, and it's making those decisions on data that's outdated, it's really, really, really bad. Obviously, you don't want to buy a stock if you're doing like high frequency trading. You're making like, tons and tons of trades every minute. you want to make sure that you're making those decisions on your trade based on data that's up to date. And if your write is writing to the database before your read is reading from the database, then you're going to be constantly getting like out of date information. And that's called a race condition. It is essentially when a read function and a write function, or two write functions, are trying to write to the same data and read from the same data at the same time, and that leads to errors. You have other race conditions where, let's say you've got a file and you're working on an operating system that only allows writes to that file one at a time. So if you've got a file here, and you've got a function that has been multi-threaded that writes to it. And, you might run this for days and days and you run into no problems. That's the really ugly part about race conditions and tons of different areas, is that race conditions are logic errors, meaning your code is going to compile. It's going to probably run perfectly fine for a certain period of time. And then you're going to start getting those errors over time. Sometimes those errors don't even cause errors like to pop up in your code. It's not going to pop up saying, hey, something goofed up, there's something weird. It might just be continuously writing junk data to a database. It might be continuously creating very dangerous security situations. There are actually race conditions within security that cause some, pretty serious vulnerabilities within web applications specifically. If you want more information on those, I think Dakin actually is a really great person to ask about that. Like she's got some great research on race conditions. I'll link to her Twitter bio somewhere. But in the case of what we're talking about here, you've got one write function that's been multi-threaded. So you've got T1 for thread 1, T1 write, and let's just say there's two threads, T2 write. And you might have no problems. You might have T2 run, and then T1 run, and then T2 run, and then T1 run, and then T2 run, and for days and days you've got no issues with both of these threads writing to the same file at different times. So these might be happening within seconds of each other, but they're not both accessing the file at the exact same time. But at some point, you're going to have T2 and T1 both try to access that file at the exact same time. And your operating system is probably not going to like that. The exact same thing can actually happen with databases. So we talked about UUIDs last section, I believe, is when we started talking about UUIDs. And the idea behind UUIDs is they're all supposed to be unique. That's why you typically see UUIDs created based on timestamps, meaning timestamps that are down to the millisecond. The reasoning there is if you've got multi-threaded applications and you've got one thread that is creating a timestamp of 0.005, and then T2 is creating a timestamp of 0.006, and then T3 is creating 0.003. And all of these are writing to a database, and there's no problem because they're all unique. So you've got this database over here that is just happily taking all of your data. But let's say, because you're not using the correct level of granularity with your timestamps, you get timestamp 4 that runs at 0.007, and thread 5 that runs at 0.007. And both of these try to write to the database. You're going to get an error because your unique ID was created based on something that was not unique. So you're probably creating a duplicate unique ID, and those two things are not going to write correctly to the database. Now, it may be fine. It may exit or error out gracefully. As you saw before, anytime that we tried to push something that had a non-unique unique ID, it just gave us an error and said, hey, don't do that. And as long as we handled it within a try except block, we were fine. But in a lot of cases, that may not be the case. You really, really want to make sure that you design your, your multi-threaded applications to be race condition proof. And we're going to show that in our example. Our example is actually a really, really good one because we will be running our analysis which is going to be all about reading from the database, separate from our scraping, which is obviously write heavy. So with ours, we're going to be creating multiple threads. So let's just say, I think we're going to stick with a size of, let's do 3. So we'll have T1, T2, and T3. Now, we're going to kind of wargame this and figure out scenarios where we might create race conditions. And I'm going to explain why none of them really matter, even if there were a race condition involved, because thread 1 is going to be handling Apple, thread 2 is going to be handling Microsoft, and thread 3 is going to be handling Tesla. So if we create our unique ID, UUID, based on the ticker. Well, here, let's talk about like a scenario that may not be bad, or that may not be good. So let's say we just use a timestamp. That's not necessarily bad, because we might use the timestamp that is like down to the millisecond, and there's almost no way that we're going to get all 3 of these threads, or even 2 of the threads, to run at the exact same millisecond and to return at the exact same millisecond. This could be like, it could be off by several milliseconds just based on the ping to the page. It could be based on, how fast your processor is running, or what temperature it is in your room, or anything like that. Like, it's going to be off by at least a millisecond. So you're really not too at risk with, having unique IDs just based on the timestamp. Now, if we wanted to really proof this, we could do the timestamp plus the ticker. And here's why that's proofing it. If we've got AAPL 000005, even if Tesla also runs at 0000, these are all obviously fake timestamps, 05, the unique ID is going to be Tesla. And the way that we're writing our code, there's no way that Apple is going to run at the exact same time as Apple. You're just not going to have a race condition with your unique ID there. So we don't have to worry about it there. And because we're going to be doing our analysis separate from our scraping, we're not just incredibly worried about race conditions with respect to reading for the point of analysis at the same time as writing for the point of scraping. So those 2 things can be done concurrently, or they can be done non-concurrently, and we're not too worried about it. If we were building a complex, like high frequency stock trading bot, then yes, we would need to worry about that. And there's a lot of complexity that goes into fighting race conditions with that. But in this case, since we're separating everything out by ticker, and we've got essentially a foolproof way of designing good unique IDs, we don't have to worry about it as much. So let's go back to our code and let's start talking about actually coding multi-threaded, multi-threaded solutions. And the reason why I had this time test right here is we're going to test to see how much faster this runs. And it's kind of unfair because we're going to design it to be unfair. But we're going to save the time right here. Well, at least try to. Copy that. And single threaded. There. So that is our time for single threaded. We're also going to save our time for multi-threaded. And we haven't done that yet. So here's how I like to do things with multi-threaded applications. I like to create a batch size. So batch size. And ideally you know the exact size of your array that you're going to be marching through. So here we've got a prime number actually for our array size. So that's imperfect. Let's add another one. I wish I had like a chat open or something like that to give me a random stock. Let's do Robin Hood, just because that's a meme stock too. So Hood. And we're going to create a low of, let's do $34. a high of $36. So disclaimer, because I didn't do it before, I have no interest in really any of these companies. I don't think I'm invested in any of them. If I am, it's very, very minimal, and I'm not interested in pumping up Apple. Like I don't have that kind of clout, so I'm not super worried about that. But just know I'm not like trying to get you to invest in these companies. Obviously, I'm not a financial advisor. This is about web scraping, not about financial advice. Anyways, so now we've got a nice even number, and we can define a batch size of, let's do 4. And what that means is we're going to divide our data up into 2 groups of 4. And the reason why we're doing that is we're going to create 4 threads, so 1 thread for each piece of data within that batch, and we're going to run all of those threads concurrently. The reason why you create batch sizes, there are a couple. One, you want to watch how many requests you're sending to the server at once. So obviously with your batches, if you're creating a batch size of 4 and you've got 4 pieces of data in each batch, you're going to send 4, you're going to be going through your scraper, the scraping part of your spider or your scraping algorithm. You're going to be sending 4 requests at a time, or you're going to be running through that process 4 times. So if that process involves 2 separate calls to the server, then you've all of a sudden got 8 requests that you're dealing with all at the same time. Now, we've got a data set of 8 different stocks. Obviously, that's very minimal. Worst case scenario, we create 8 threads, all 8 of them run at once, and we send 8 requests all at once to Yahoo Finance. We would be fine. But we don't want to do that. We want to make sure that we're doing this ethically, and we're making sure that the way that we're doing all of this is up to par with kind of like a professional manner of scraping data. We don't want to just send tons and tons of requests, and we want to make it to where if we wanted to scale this, we would be able to add 50 more stocks to this, and we would still be doing it ethically and reasonably. So we've got our batch size of 4, and that I chose arbitrarily based on our data set size. If you don't know your data set size, you can pick something easy like 2 or 3 or 5 or things that are like, I guess, common factors of different data sets. It doesn't matter a ton, but it is kind of good if you can kind of reasonably divide it into, chunks of similar size. So, speaking of chunk, our first chunk, chunk is going to be equal to an array. Okay, so now that we have our batch size, we can actually start processing the data in a slightly different way. So we're going to create our batch, and we're going to set it equal to initially stocks underscore object dot items all the way up until batch size. So this is how you do that. BATCH dot size or underscore size. And this is going to grab all of the items up until batch size, I believe, non-inclusively. Meaning it's going to grab 0 through 2 or 0 through 3. I can't remember exactly how it does it. I'm going to add a +1 just in case there. And let's test it out by length of batch. So this should be 4, if I'm thinking of this correctly. Dict items object is not subscriptable. We probably need to throw this into an array or a list and then subscript it. Yep, that works. So that is size 5. We want it to be size 4. Okay, so that is inclusive. There we go. Okay. So now we've got our initial batch, and we've got it set at the correct length. Now, here's how we're going to do this. So for x in range 0 to 3 is going to stay the same. All of this is going to stay the same, and this is going to be instead batch. And then at the very end, we're going to set batch equal to batch from our batch size until our batch size times an index. I'm going to explain why here in a second. I promise. Batch size times index. So we're going to do it the exact same thing, the exact same way here. So index is going to be equal to 1. Then we are going to increment this index. Index is equal to, well, let's do it this way. Index plus equals 1. All right. Okay, so let me explain this. Basically what this is doing is we're at first setting index equal to 1, which in that case, our initial batch is just going to be the first 4 objects within, or the first batch size objects within our total stocks underscore object list. So it's just going to grab the first 4 objects in this case, because it's going to be 4 times 1 here. Then this is going to run. It's going to actually run over the first 4 objects, and then at the very end, it's going to increment index. So now index is equal to 2. And now we're going to grab the stocks objects list from the batch size, so basically from the 5th object all the way to the 8th object, so batch size times 2, so the 8th object. And then it's going to iterate over that, and then after that it's going to be, the index is going to be equal to 3, so it's going to grab the batch size times index minus 1, so that's how we need to do it. I actually had it wrong. So it's going to grab the batch size times the index minus 1, so in this case it's going to be 2, so from the 8th object until the 12th object. So it's going to keep iterating through this way. Now obviously we only have 8 objects here, so it's going to be kind of boring at first. But that's essentially how that's going to work. And let me explain that again. So again, we're starting with a batch size of 4, and let's just pretend we've got tons and tons of objects here. So we start with a batch size of 4. We are setting index equal to 1 initially, and we are going to grab the first batch size object. So in this case it's 4. We are going to grab 4 times 1 object, so 4 objects. We're going to run through this once, and at the very end we're going to set index equal to 2. Now we're going to grab the next batch. The next batch is going to be equal to all of the objects within a certain window. That certain window is going to be the batch size times the index minus 1. The index minus 1 and the second run, in the case of the second run, is going to be equal to 1. It's going to be equal to 1, duh. So it's going to grab 4 here. So it's going to start at the 4th object, and it's going to grab all the way up until the 8th object, because this is going to be 4 times 2. Then on the next run, index is going to be equal to 3, and this is going to grab batch size times 3 minus 1, so batch size times 2, so 8, all the way up until batch size times 3, 12. So this is going to continuously move that window over and grab batches based on that window. It sounds confusing, but if you kind of visualize it, it makes a lot of sense. I guess I could actually go as far as to explain this visually, since I say that, you need to visualize it. It's kind of rude of me being like the teacher of a course. So let's run through this. And I'm going to run through it as if we've got 24 objects within our list. So let me erase all of this nonsense. So we've got 24 objects. So, well, no, that's an eraser. 24 OBJs. So on the first iteration, we've got a batch size equal to 4, and an index that starts at 1. So this is initially going to grab the objects from 0 all the way up to batch size times index. So we're going to abbreviate this as BS because it's funny and also shorter, so I don't have to write as much. So that is going to grab objects from 0 all the way to 4, because that is 4 times 1. Then it's going to increment the index. So index now is equal to 2. So now instead, we're going to redraw this the way it actually is. it is going to actually be grabbing all of the objects from index -1 times BS all the way up to index times BS. All this is really doing is this is going to be equal to 0 times BS, so 0, all the way up until 4. On the next iteration, index is equal to 2. So it's going to be grabbing objects at index -1 times batch size, all the way up until index times batch size. So it's going to be grabbing objects from 2 minus 1 times BS, so that is going to be equal to 4, all the way up to index, which is equal to 2 now, times the batch size, all the way up to 8. So it's going to be grabbing 4 total objects here. So now index is equal to 3. It is going to be grabbing index -1 times BS, all the way up until index times BS. Now that index is 3, it is going to be 2 times BX, which is 8, all the way up until 3 times BS, which is 12. So we've worked halfway through it here. That should hopefully show what I'm talking about. This is going to end up grabbing item 8 all the way up until item 12 when it's equal to when index is equal to 3. When index is equal to 2, it's going to be grabbing objects 4 all the way till 8. And it's going to keep going through this. It's going to keep moving that window to create our batches to the right until you're essentially out of objects to pull out of batches to create. So I hope that makes sense. And basically, we've got to program in a way to make sure that we do in fact have a good batch. Our batch is actually, our batch is actually going to be like valid once we create it. And here is how we do that. So we're going to be, for x in range 0 to 3, we're still going to be running through it 3 times. For key and value and batch, so if index times batch underscore size is greater than length of stocks underscore objects dot items, and we're going to call this a list just to make sure that that actually works. And we're going to inverse that, so if it's not greater than, then we're going to do all of this stuff. There we go. And here is going to be where we actually end up doing our multi-threaded stuff. All of this stuff has basically been in preparation to do our multi-threaded stuff. So for item in batch, let's do for key value in batch, we're going to say our ticker is the key. So ticker is equal to key. Our low is equal to the low. Our high is equal to the high. Our price is equal to that. And this is going to be where we actually start multi-threading stuff. So let's move all of this over. And basically what we want to do is we want to take as much of this as humanly possible and put it in its own function. Now here's why. Every single thread can only run on one specific function. Now that function can call other functions, but essentially you want to pull all of your operative stuff out into one function. So we're going to create a function up here called def service thread. And we will define how this runs. Return nothing for right now. And we want to basically take all of this meat in here out and put it in that service thread. So even our database functions here, we're going to pull all of those out as well. We're basically just going to leave our batch functions, and we'll leave our sleep out as well. We're going to take all of this and stick it within our service thread function. And that immediately formatted badly. Now, we want that object, so the key and value. That should satisfy everything there. And we need our stocks object. So we'll pass in the key, the value, and the stocks object there. And I promise all of this stuff is going to end up paying off. So now we need to actually create our threads. I promise this is the part that it actually gets interesting. We're going to actually start multi-threading stuff in the multi-threading episode. All right, so first we need to import the threading library. So let's import that over. Let me make sure I actually do it correctly. It is just import threading. Import threading. All right, so now that we've imported that, we can start creating our threads. And we need to create an array that is actually going to be tracking all of that. Well, I guess I created this twice, so that's going to cause some issues. So let's go ahead and do less indent there. All right. Now let's create our threads. So we actually have to track all of our threads right now. So threads is equal to an empty array. And we're going to end up appending to that to track which threads we've got open. Because basically when you open one thread, you have to track whether or not it's been closed. So let's create our thread. So thread is equal to threading.thread target. And the target is the function that you're actually going to be running. So that is going to be service thread. Service thread. Our args is the arguments that we're passing to that. We need to pass the key, the value, and the stocks underscore object. So that is the arguments that we're passing, and I believe that's all you actually need for the initial creation of that thread. So after you've created your thread, you need to start it. So thread.start, and that is going to actually run the function with those arguments there. And we're going to append to that threads array. Append thread. So this is going to happen within our batch. We're going to append all of these threads to that array right here. And after we leave that for loop right there, we can do all of this outside of there. All right. Now we need to actually join them together. And what join means is it's actually just waiting on those threads to finish and joining them back together with our main thread. So our program is actually going to be running an initial thread. It's going to be spawning 4 new threads off of that. And then it's going to join all of those back together with the initial thread. So we're going to set joined equal to 0. So for thread and threads, we are going to wait on them to join back together. So joined plus equals 1, print joined out of the length of threads. And basically what that's saying is we have now joined X amount of threads out of the total amount of threads that we created. And we are going to do thread.join. There we go. And what this is doing is it's basically just joining all of these threads back together with our original thread. and making sure that we don't have just threads running wild and, running away from our program, which is not what you want. And then we're going to sleep after that. Now, with all things multi-threading, you can just about guarantee that you've got an error somewhere. So we're going to debug this together, and hopefully I'll learn more than you do. So we're going to clear it 1,000 times for luck, and let's run it. Yep, see, immediate issues there. So we've got con not defined there. Oh, so we're not passing our connection object. So we actually need that. Concur. So let's pass that in. Not ideal, definitely not efficient. Concur. But for right now, it's the way that we're going to do it. Oh, actually, we did the thing that I said would never happen. Shockingly. We had an overlap with our timestamp. Wow. I'm actually fairly shocked that that happened. So everything that I told you was a lie. I was totally wrong on that. It looks like we did have a unique value error there. So let's go ahead and create a better timestamp. That's going to be fairly easy to do because all we really need to do is append the ticker to it. And theoretically, now I'm not as confident, but theoretically, we shouldn't run into that issue anymore. So let's just do it in our insert. So let's do ticker plus timestamp there. So let's run it again. And nope, that didn't work either because we've got to convert that to a string. So we are actually creating these threads successfully, which I'm just shocked at. All right, so we're running through it. And it appears we have done it. And honestly, this is running way faster than I expected it to. So let me make sure that this is in fact running correctly. Running through the list for the X time from 0 to 3. So that should be doing it. And it's creating a batch. We're incrementing index every time. Let me make sure that this is working, because if this is working, then it is way faster than I expected it to be, which is fairly cool. Oh, this needs to be a while. Maybe that's the problem I'm running into. Yeah, that's definitely the problem I was running into. Well, that's dumb. Alright. So, basically the problem that I was running into is that I was running this in an if statement instead of a while loop. So basically we need to run this through while the length of the batch is greater than 0. So that's going to actually run it, iterate the batch, all of that fun stuff. Okay, so let's recap. We're creating a stocks object here at the very beginning, and that's just an empty dictionary at first. We are going to load all of our stocks object or our stocks data in from this file right here. It's going to contain tickers, low prices, and high prices to alert on. We're going to load all of that fun stuff into our dictionary, with the ticker being the key and this object with the low and high prices being the value. We're going to create our connection to the database. Very simple stuff there. We are going to create a start time, which is going to be when we actually start running the program, and a batch size. This batch size is going to determine how many concurrent threads we can create at one time. So it's basically going to take the list of stocks that we've got. It's going to divide them up into pretty slices, pretty batches, and then it's going to process those batches according to the size of the batch. So we're going to run through this list 3 times in this case in order to kind of test the speed of our function. And we're going to create our initial batch. Our initial batch is going to be from 0 all the way up until batch size times index. So fairly simple stuff there. It's going to basically be all the way up until batch size. And then we're going to run through as long as batch actually has objects in it, we are going to keep processing. So we're going to create an empty array that's going to hold our threads. Then for every single object within our batch, we are going to print out that we're scraping it, and we're going to create a thread that is going to run through this service thread function. And what this service thread function does is it is actually the workhorse of the entire program. It is going to be what actually, I guess I could have simplified this by writing value. I'm going to nitpick on this. So basically, it's going to be what actually does all of the work. The reason why we broke it out into its own function is because every single thread has to have one specific function that it starts at. That is its target function. So high is equal to float with value at high. So this is the function that it's actually going to use. It's going to be what takes all this data out. It's going to be what actually scrapes this data from the web page, and it's going to be what processes whether or not it needs to alert. And it's going to insert the information into the database. So after it creates 4 different, or the size of the batch, 4 different threads, it is going to start all 4 of those threads, and it's going to append them to this list. Then, after it has created all of the threads, it is then going to join them back together with the main thread. And what that basically means is you've got a main thread that's running your main function here. It creates all of these spindly extra threads off of it, and then it waits for all of those threads to rejoin the main thread to basically finish running and join back with the main body. So it's going to wait on that, then it's going to sleep for 3 seconds, it's going to increment the index, and it's going to create a new batch. So that's pretty much it. It ran in 21 seconds, which is a quarter of, I think, how fast it ran when we were single threading it, which is wicked fast and pretty awesome. And it only took us an hour and 11 minutes of raw time to record this. So here's the thing. Multi-threading is awesome. Multi-threading can speed things up massively. I mean, we could run this 4 times as long as we ran our single-threaded application, and it would still run faster. So that, I mean, it's wicked cool, but it obviously adds a lot of complexity. I had to restructure the entire running portion of our spider or our scraper just to get this thing to run in a multi-threaded fashion. Sometimes that is worth the effort. Sometimes it's not. If you're doing something very, very simple, then you may not need to multi-thread it. If you're doing something complex, or if you're doing something that really, really cares about the time that it takes to run through, then yeah, you definitely need to multi-thread it, or at least you need to think about it. We talked about race conditions a lot in here. That is also a very important consideration. Obviously, in this case, there is no worry about race conditions, except for that one really crazy case where I ended up with a UUID conflict based on like a millisecond timestamp, which is wicked cool. But yeah, that's really about it. Y'all take it easy. I will see you in the next video. We're going to start talking about some seriously cool design stuff that's going to take your spiders and scrapers to the next level. Take it easy.